let's get started. What have we got today? Well, today we have got trig identities. And I made another setup because I lost the last one, so I'll try and hold on to this page for a few days anyway. There are two kinds of trig identity questions. They're going to be, the first one basically just says simplify. And we've done a few of those on Thursday, and we're going to continue with them today. Get that type of question finished. And then the second type is prove that something's true. So in simplify, they just say to you, simplify, some expression. I'm just making some up, right? They say simplify that. In the prove identities, they actually tell you what it should be equal to. So in some respects, that's easier. So you might get, for instance, something that says cos x over secant x plus sin x over cosecant x is equal to 1. So you're being asked to prove that this is equal to that. The problem with simplify is that you don't always know if you've simplified it as much as possible. Because sometimes you'll do it and it looks really nice and you think, I'm finished. But there's maybe one more step you could have done that you never noticed. At least when you've got a prove identity, you know that this has to equal 1. So your job is to make this equal 1, right? So in a way, that's kind of nicer, as I said. And for the most part, they're not easy. And the worst kind are ones with fractions.
Isn't that equal to?
No, actually, it's equal to 1. I'll hold that one now. Keep it as one of the ones I'll do. Ends up being cos squared plus sine squared, which is 1. Okay, so let's start with our first kind, which is simplify. And this is a version question 5. And so we have secant theta take away cosine theta all over sine theta. Yeah. Now, there are lots of different types of identities that we have to deal with. And so I can't say, step 1, step 2, step 3 kind of thing, because they vary. But there are some general rules that work a lot of situations. And one of those is turn everybody into sines and cosines. You can't think of anything to do. So I'm going to take the secant. I'm going to call it 1 over the cosine of theta. Now you're going to end up with weird looking fractions. We do not like fractions with fractions in them. One of the ways to get rid of that issue, in this case, if it's a single fraction with a fraction on the numerator, is to multiply by a special version of 1. In this case, I'm picking cosine theta because of that guy. And as long as everybody in the top gets multiplied by cosine theta, and at the same time, everyone in the bottom gets multiplied by cosine theta, this is algebraically valid, right? It works. 1 over cosine theta times cosine theta gets you 1. Take away. Cosine times cosine gives me cosine squared theta. And on the bottom, I have sine theta cosine theta. Are you comfortable with what I did there? Does that seem reasonable? We're good? Now, this bunch of guys over here, they're not, there's others, but these are the main ones, right? These particular identities, these are things you know are true, or you believe me when I tell you they're true. The reciprocal ones are basically how you can turn sines and cosecants into something else, or reciprocally something else. And these ones here are all called the Pythagorean identities. That's the one you know, right? Sine squared plus cos squared equals 1. But if you rearrange it, you can turn sine squared into this. You can get cos squared out of that. And there's another one here with secants and tans. These are called Pythagorean identities, I think, because they come from special versions of right angled triangles. Now I'm looking at this guy here, 1 take away cos squared. And I'm looking at him because he's pretty big and ugly. And I want to see if there's anything in this list that I could use to change it into something a little bit nicer. Can anybody see what 1 minus cos squared could be rewritten as?
Sine squared?
And if things are nice, which sometimes you're lucky and they are, you might get a cancel or a factor and a cancel here, right? Can you see a cancel here? What can cancel?
Sine.
Right. That'll cancel with one of these, still leave a sign behind. So what we now have is a nicer answer. I mean, it's taken a while, but hasn't it? Look where it started life off, right? Look where it is now. And at this point here, it's dead easy to think, I'm done, I'm good. But it's always a good idea to have another look. Is sine theta over cosine theta somebody in this list?
Tangent theta?
And I think when you get to that stage, would you agree you can't do any better, right? You've got a single thing. How simple can it get, right? That's it, you're finished. So if you're doing WebAssign and you put an answer in like that and you're comfortable you've done nothing wrong, but it says you're wrong, right? WebAssign says no, then you're probably going to have to just, have a little hunt and look for things. There are a rule that doesn't really matter here because of what this and, but if you ever get something like, say, this, right, just pretend I had that, right? I simplified it, I got that. There is a rule that says we don't like fractions. So that sine gets turned into that cosecant, right? And so that might be your answer, but this is the one WebAssign is looking for. So occasionally you'll get a fraction at the end. If you do get a fraction at the end, well, you rewrite it as a product. That's kind of the convention. We don't like fractions. So far, so good. Right. Let's try this one. Now, there's no point in turning this guy into sines and cosines because he already is. This one is not as bad as it might seem. Well, factoring is a good strategy. Can anybody see a common factor in these two expressions?
Cosine.
I see a cosine as well. And that leaves me with a cos squared x plus a sine squared x. And hopefully you will say, I know this guy, he might be written back to front, but I still know who he is. What does cos squared x plus sine squared x get you?
One.
1. Isn't it the same as sine squared plus cos squared? It doesn't matter, right? And since it gets you 1, there's a nice surprise. That guy simplifies to that. So let's go for the scary ones. The fraction ones are, in my opinion, always going to be the worst ones. And if you're hearing a lot of noise in the background, I've already mentioned it, but not everyone was here when I said it. We are getting a new roof, so there's a whole load of guys up in the roof banging and scraping them. Whatever. Okay, one fraction plus another. You are going to have to join these two together to simplify it. And when you are dealing with fractions, the algebra is just going to be uglier. And to add two fractions together, they need to share a common denominator. And don't write this down. I just realized I need more room. So if you want to add two fractions together, you need a common denominator. So I'm going to multiply this guy by 1 plus sine alpha, top and bottom. That's essentially multiplying this fraction by 1. What version of 1 do you think I'm going to use on the second fraction? This guy get multiplied by 1 plus sine theta. So it's not that guy, but this guy. What's this one going to get multiplied by?
1 minus sine.
Now, the advantage of doing that is, do you now see that both those fractions have the same ugly common denominator, right? Which is basically these two guys. So I can do a single fraction now. A 1 take away sine alpha and a 1 plus sine alpha. And that times that gets me 9 plus 9 sine alpha. And that times that gets me 9 take away 9 sine alpha. Are you comfortable about what I just did there, right? 9 times this guy, 9 times this guy. They share a common denominator, so it's now one big fraction. And some neat, well, some pretty nice combinations. The 9 and 9 go together, the other two kill each other off. And now we have an answer that looks quite nice, but is not as simple as it could be, right? Any thoughts what you should do next then? If this could be simpler, what do you think you need to do next to find out?
When you factor out the denominator, it would just be 1 minus sine squared alpha or whatever that is.
Yeah, alpha. Yeah.
And then that would be 1 over cosine squared.
Yep. And what about the rule we don't like fractions? Because that's the last rule we need to deal with now.
So multiply by the reciprocal.
So we will call it secant squared alpha. And there you're finished. So that was the original. There we go. Would you agree it's simpler, right? Nicer. Fractions are ugly, right? You got to deal with them. They're not pretty. Okay, I think I've got one more fraction I can do with you. Here we go.
Can you
Was
put
that
the
eight?
other one? Can you put the
No.
other one back for a second?
Sure.
Thank you.
I think I got my numbers back to front. I think this guy here is actually 9, or a version of 9. And this guy here that I'm about to do is a version of 8. Okay, there's the original. This fraction plus that fraction. We have been asked to simplify. That means that we need to add these two fractions together by doing something so they now have a common denominator. So this guy is cosine u, this guy is 1 plus sine u. So if I multiply this one with the 1 plus sine u, and I multiply this guy by cosine of u, I can now combine the two fractions because they will be sharing this times this as a common denominator. Now, if you multiply this guy and this guy, you don't get 1 plus sine squared. If you FOIL it out, you get a little bit more than that. You get 1 plus 2 sine u's plus sine squared. And if you multiply this guy and this guy, you just get cos squared u. So FOIL these two out and you get those three terms. Cosine times itself, you get that term. Can anybody see anything on that top row that might, get this guy out the way now, that might work with one of these identities?
The sine squared plus cosine squared, that would equal 1.
And add it to that one, and now we have 2. Are you all comfortable with that? Right? Sine squared plus cos squared gets me 1. 1 plus the 1 you already have is now 2. Right? Every line gets closer to where it needs to be. Every line it gets a little bit nicer. Can anybody see something that we could do with the top row, the numerator?
Factor out of 2.
And something kind of magic happens. Do you see something magic happen? We get a cancel, which means that we have a fraction, a very nice fraction. But remember the rule, we don't like fractions. So 2 over cosine, right? 2 over cosine, where is it? There, becomes 2 secants. Never finished. So that original one, I mean, look how messy that was. Look how elegant it ends up being. Still points. Any questions on the simplifying? Anything that we've done so far you're not comfortable with? Are we good? Right. So turn everybody into sines and cosines. Collect things. Use identities. Make 2 fractions 1. Techniques like that, right? A little bit of A, B, and C, right? Different questions involve you doing different things. So let's move to the last part of this section, and that is proving identities. And I think I kept one. Right, let's do this guy. In an identity question, you are essentially told what the thing simplifies to. And what you need to do when it says prove the identity is, for the most part, take the left-hand side and simplify it. And simplify it to the point where you get 1. Right? And you have to do it in such a way that it is understandable. You can't like get halfway through and get stuck and then just say, yeah, it's obvious it equals 1, right? You got to do it so that every step leads slowly but surely to that thing. And identities have their own little issues, but we share pretty much the same strategies as before. Things like turn everybody into sines and cosines is a good one, right? Factor things is a good one. Combine 2 fractions is a good one, right? Those are the kind of strategies we've used. Right, I'm looking at this guy, cosines with secants, sines with cosecants, right? This question is not actually too difficult once you realize that this secant can be written, and I'm taking this really slowly, and this cosecant can be written like that. Would you agree that cosine x times 1 over the secant is just a strange way of saying that? Right. Now, does anybody know, looking at this side here, what 1 over secant gets
A cosine.
There's Chloe. Now that gets me cos squared x plus sine squared x. Would you agree equals 1 is kind of acceptable, right? If you get it to something over here, you know you've done it. So it's not 2k, right? It's only 1. Right. Let's try a version of question 10. Sine theta on the top, tan theta on the bottom, and we have to prove that it's equal to cosine theta. Okay, any suggestions about what I could do with this fella here? Because this is the guy we have to work with, right? We want to prove it's that, but this is the guy we're going to work with, right? This is the guy we're going to change. Any suggestions for anything that could be changed here, hopefully to eventually get it to there?
We could separate it to be 1 over tan, which will be the same as cotangent,
Correct.
and then change cotangent to cosine over sine.
And what is so nice about cosine over sine?
We could cancel out cosines.
And if you do, bingo, right? You proved. Yeah, you got what you needed, right? You got a cosine. Sneaky. Cool. Let's do one. Oh, shush. Yes, you, shush. Never listens to me. Right, there's an identity. Prove that cosine x plus sine x all squared is equal to that. Now, I'm not going to do this question, but let's talk through it. What do you think you need to do to the left-hand side? What's your choices? Because there aren't many, are there? What would you do to the left-hand side?
Square root it.
Ooh, you're thinking of solving equations, but we're not trying to solve an equation here. Aren't we trying to prove that this is equal to that, right? So I have a different approach. If you couldn't do a square root, what else could you do with cosine x plus sine x all squared?
I said to square it.
Oh, did you say to square it? Oh,
Yeah.
you know I'm old and you've got an accent. You really have to do something about that accent. Could you please not have it? Watch the elevator skit. That's really cool. Oh, it wasn't the elevator skit, it's the aircraft skit. Okay, if you foil this out, can you trust me eventually you get that, right? So this one, now this one, cosine x over secant x. I think I did this one. I did. Let's move on. 30. 2 cosine squared x, take away sine squared x, is somehow going to be the same thing as that guy. Now, everything here is already in sines and cosines, so that ain't going to work, right? There isn't a fraction in sight, so that's not going to work. They don't share a common factor, so that ain't going to work. But somehow or other, this is going to be that. There's somebody over here that we can use. And it really depends on what they want you to prove it's equal to. Do you notice they want you to prove it's 3 cos squareds, right? So which of the guys over here, in other words, which of these two should I change using one of these guys? Which one of these two should I change into something else so that you end up with this guy. And there is a clue on what this guy is and what you've got to start with.
You could change sine squared x to 1 minus cosine squared.
Remember to take it away. And that becomes take away 1, take away a negative is add it. And way. All the pieces just fall out, don't they? And you got what you were after. Do you see the uniqueness in some of these? You know, it's not one method fits all, isn't it? You got a list of guys you can use, you've got a bit of algebra you can use. You got to look at what you've been asked to prove and kind of figure out what would be a good strategy to get this to turn into that. So in this case, it was simply just finding the right guy to change. In this case, it was sine squared. And then it kind of came out pretty quickly. Okay. Next one is version 14. Okay. Oh, I could do this at least 2 different ways. They'll both work. So at least that's something, right? There's more than one way to skin a cat. Can anybody see any, starting point? You don't need to figure out the whole thing, but is there anything you might want to change or turn into something, or, look at these guys and see if there's anything that fits? Anything there that you like?
The first thing can be sine squared x. I don't know if that's going to help.
It is, because if you make it simpler, it's probably going to help, even if you don't know yet how it's going to help, right? But it will. Now, is there anything cotangent squared could be turned into? Look over here. Is there anything cotangent can be turned into? Then you can square it.
Cosine over sine.
That one, right? Thank you. I think if a workman falls through the roof, then we know what's happened. So it's going to be that guy, right? Just square everything. Okay, so I've turned 1 minus cos squared into something a little bit nicer. I've turned cotangent squared into cosines and sines. That's good. What do you think I'm going next?
Now you're just going to multiply it in, so it's going to be sine squared x plus cosine squared x.
Because these cancel out. And do you know who he is equal to?
1.
1. You're finished. Cool. They're little challenges. I love little challenges. I like big challenges as well. I mean, once you figured out to do, what was that, 3-liner? Wasn't that big. Whoa. Whoa. Oh, there are so many different routes. They actually, in the website, give you a route to travel. That's fine. And so we will do that. But I've got this guy, and I've got this guy, and it ends up being this fraction. So I'll take any suggestions, anything you could do. Remember, the left-hand side is the guy you fix, right? You change. And the
The-
right-hand side is what the answer should be when you're finished.
The numerator can turn into secant squared.
It can. You're right. And 9 times out of 10, that's exactly what I would have done. I would have. But I'm not going to do it this time. Not because that's not a good idea, because it is, but not for this question. And you see that this answer over here doesn't look like there's anything secant-y squared about it. No, that's not a good verb. But can you see it? It don't look like it. And that's the only reason I'm not going your route K. Now, I could be proved wrong. In other words, if you've got time, try that route and just see where it goes. But there was nothing wrong with that. It was a totally sensible approach. And in many questions, that would have been the right approach, but not this time. And it's only because of what this looks like. That's the only reason I didn't go that way. Give me another thing you could do then.
You go the weird route and just change, what is it, tan? So my question is, would tan x equal the same thing as sine squared x or cosine squared x?
Yes.
Well, go that long route.
Yeah. Not the route I would choose to do, except the answer is so ugly, I'm pretty sure that's what is going to happen, right? Can you imagine if we turned the bottom into secant squared? Can you imagine that's probably not going to play well with this? I'd probably end up with another answer that's really pretty, but it wouldn't be this pretty answer, right? It'd be some other pretty answer, right? But not the one I need to get. Now, after turning everybody that's can be turned into sines and cosines, which is a pretty common strategy, I now have a fraction with fractions in it. What special version of 1 am I going to use to get rid of the fractions?
One
plus.
One plus the sine squared over cosine squared
Ooh,
over 1 plus. No, would that be
no,
too messy?
that's what you do if there were 2 separate fractions. You want to make them 1. This is already a single fraction. Its problem is that there's fraction bits in each. And I want these cos squares to go away, essentially. So the special version of 1 I'm going to do is that one. Okay. I'm going to multiply by special version 1, but you see the advantage of this is, well, let's what's going to happen. That times that guy is going to get me cos squared u. That ugly fraction times this guy gets me sine squared u. The bottom, that times 1 gets me cos squared u. And this fraction times this guy gets you negative sine squared. Yeah. Wait a minute, isn't the top 1? Can't we stop now? Isn't that what we were trying to prove it was equal to? Since we've got time, I'm going to try Katie's approach just to see where it goes, because I could be wrong, it might work. So we're back to this guy, right? And if I remember, you said, let's make that secant squared u, okay? What you want to do?
The top is secant squared.
Oh, right. So make the top secant squared. Okay, what are you going to do with the bottom? What are you going to do with 1 minus tan squared u? Because it's not one of these guys. It's not one I can see. No, it's not. What do you think you might do to the denominator then?
Make the tangent into sine over cosine.
Yeah. Now, I still have a problem, right? I have a fraction inside a fraction. And can I multiply by a special version of 1, which ends up being cos squared u? And on the bottom, that times that gets me cos squared u, and that times that gets me negative sine squared u. Your method is going to work. What does secant squared u times cos squared u actually get you?
1.
Gets you 1, or 1 squared, but it gets you 1, right? And hey, we're finished. Isn't that the same answer? So I talked you out of a good strategy, but the only reason I talked you out of it is because when I looked at what the answer was, I couldn't see how that was going to happen by making the top secant squared, right? But actually, it did happen, which means it's a totally valid technique. Oh, perfect timing. Last one of this batch. Secant squared x plus cosecant x. I said squared, it's not. On the bottom, tan x plus cotangent x. And evidently, that entire fraction ends up being cos x plus sin x. Okay, we need some strategy here. What you going to go for? What do you think we're going to do with these guys?
Make them all into sine and cosines.
Okay, so a secant is 1 over a cosine. A cosecant is 1 over a sine. A tangent is a sine over a cosine. And a cotangent is a cosine over a sine. Right, that is like the ultimate version of horrible. We don't like fractions with fractions in it. We've already dealt with this a couple of times, but this is like the ultimate version, right? This is about as hard as these guys can get. What special version of 1 will get rid of all these sines and cosines so that the top fraction and the bottom fraction don't have fractions in them? Whatever you do on the top, you must do the same to the bottom. So what would you do? Let me ask you a different way. If it was only the cosine that you were worried about, wouldn't you multiply the top and bottom by cosine? Right? If it was that 1 over sine x that you're trying to fix, wouldn't you multiply the top and bottom by sine x? So you want to get rid of 2 things at once. So what do you do? Say again?
So would you multiply by cosine times sine?
Yeah. As long as the top is the same thing as the bottom, aren't you just multiplying by 1? Well, let's see what that does. Might do this at the side here because there's a lot of bits. If you take the first fraction, which is this fella, and you multiply it by sine x over cosine x, don't the cosines cancel and you just get sine x? If you take 1 over sine x and you multiply it by these 2 guys, don't the sines cancel and you just get cosine x? So far, so good. Now, if you take this fraction, which is sine x over cosine x, and you multiply it by sine x cosine x, the cancels, well, the cosines cancel, but aren't you still left with the sine squared? And if you take the cosine x over the sine x, which is this term, and you multiply it by a sine x cosine x, They two cancel, and you have a cos squared. So far, so good.
So just be sine plus cosine over 1.
Which of course is just sine x plus cosine x. And isn't that what we were trying to prove in the first place? So we're finished. Aren't they fun? If you like challenges and you like manipulating algebra and just, playing about with things, you need to know these, right? The best thing in the world to do is just memorize them. I know that might be hard, but if you do memorize them, because they're in your head, when you get a question, like, what am I going to do about that? You're already probably going to say, oh, that's a 1 over cosine and that's a 1 over sine. If you have to keep doing, well, what's that guy? You can get lost in the trees, can't you? There's just so many things that might be, even though most of them don't work, it might be one of them. You have to check them all. If you have them memorized, it makes your life simple. Any questions before we call today a day?